Yeah, good morning, everyone. How are you today? Good? So early, huh? All right. Yeah, my name is Larissa Becka. I'm a specialist for machine learning and AI at AWS. And it's a pleasure for me today to be here to present to you the future of machine learning in the cloud. Before we get started, can I get a bit of a feeling for what your background is? How many of you are really students in the room? Students? Any students? Okay, like a third. How many of you work in academia? Oh, also quite a few. And how many of you are in the industry? And as a result, okay. Anyone I didn't catch? Okay. Well, the talk today will be focused a little more on the business side of things, on the industry side of things, simply because I'm a little more suited to talk about that. Before we jump into the future of machine learning in the cloud, let's first talk about why companies today are moving to the cloud to do their machine learning and AI. First reason for that is usually capacity and agility, especially for machine learning workloads, which are often very much fluctuating in their needs for compute capacity. You might need a lot of CPUs today for feature engineering. You might need GPUs for model training tomorrow. The day after, you have completely different requirements with regards to throughput and latency for your inference workloads. If you do this on-premise and with your own infrastructure, you always have to provision for peak capacity, right? You need to be able to cover all of these use cases. In the cloud, that's a little different. There, you really can use whatever kind of compute capacity you need when you need it. You can use the GPU for training. As soon as you're done, you will shut it down again. It will be available to others. On top of that, you'll be able to speed up much quicker. You don't have to wait these 2-3 months until your GPU is delivered and until you can actually start using it. That is more cost efficient, it's a lot quicker, and it's also a lot more sustainable because you don't have to provision for this overcapacity. Now, the second reason we see a lot of companies to move to the cloud are managed services. This is really about using services to build your workflows. For machine learning, that's often workflows around preparing your data, doing inference for multiple models after each other, running automatic retraining, deploying automatic changes to your model. If you do that, you often rely on what we call a managed service. It's a service you don't have to deal with the infrastructure with. You don't have to maintain the infrastructure for that. To give you a bit of an example to illustrate this, there's this AWS service called Lambda. It's a serverless event-driven service, which essentially lets you do things like whenever someone uploads a picture, you can automatically start it up. It will start as a result of the event. It will do the compute or provide the compute capacity to process that image, and afterwards it will automatically shut down again. If you upload 10 pictures, there will be 10 Lambda functions starting up processing your images. As a result, you can build these workflows a lot more easily, also build training workflows a lot more easily. The third reason we see a lot of companies move to the cloud are AI services and features. AI services, basically services where there's a pre-built model, you can run your inference directly against it, even if you don't have machine learning capacity. And features are usually parts of a service that ease the workflow of a typical data scientist. Pre-processing, for instance, or experiment tracking, you have model monitoring for models in production, you have automatic code checks potentially. All of those make your process a lot more efficient. And the third reason why we see companies move to the cloud is a collaboration aspect. You might want to share your data, you want to share your features, you might want to share your models across different teams. You might want to be able to see the experiments others have already run, and you might even want to share templates of your environment to simply streamline the process a little bit. Now, when I realized I was talking about the future, I tried to look back a bit on how we design usually new services. And we look at trends and needs of customers, but at the same time, we often look at what is not going to change over the next few years, what are the needs that will persist. And we'll start to derive some of the trends from that. I'll do the same here. The first thing I don't think is going to change is the availability, or actually the rise of compute capacity. Over the last few years, we saw that compute capacity for machine learning and AI has pretty much doubled every 4 months. This is even significantly more than Moore's law. It's primarily a result of more and more chips that are available that are specifically designed for machine learning workloads. The second thing I don't think is going to change is somewhat a lack of skills from people that understand AI well. And I don't only mean data scientists and machine learning engineers here, I also mean the business that understands where opportunity lies within AI and ML, and where we also see that people understand where the barriers lie. And the last thing I don't think is going to change, and I actually think it's going to accelerate, is a drive and an expectation from the business side that there's really going to be value in machine learning. There's not just going to be proof of concepts, but there's really applications that are driven by that. Now, based on that, we can start to derive a few trends, and I want to introduce you to 5 that I think will matter in the next few years. The first one is machine learning industrialization. I think everyone talks about it, but we've seen still company after company that is actually struggling to move past this proof of concept into an industrialization phase. But however, Gartner says by the end of 2024, about 75% of the enterprises will have shifted from piloting to operationalizing AI. Now, how is that happening? If you look at companies that do this in a mature way, we often see that they have 4 or 5 different pipelines going on there. There's usually a data pipeline that pre-processes your data in a consistent way continuously, either on real-time data or alternatively on batch data. Then there's usually a training pipeline, especially if you run your machine learning workloads in production. You don't want to retrain this model manually month after month. That's just not making sense. You will probably automate that workflow of retraining your models, maybe based on new incoming data or every month, however that works for you. And then there will be usually a third pipeline, which is called an inference pipeline. This is really where your model comes to life, where it connects to the outside world, either through inference on a dashboard or inference in an application, or even something like a workflow, where you predict churn, and afterwards you want to automatically send an email to the people that might churn soon. And then there's usually a fourth part, which we call a build pipeline, which is really a way to train your model whenever you do a code change, but then also use something like infrastructure as code to move from a dev environment to a test environment to a production environment. In the cloud, you usually separate those in completely different accounts, so that you'll be able to do changes in the dev environment, then you are able to test them in a test environment, and then only after that you move to a production environment where mostly people don't even have the capability to really do manual changes, simply to ensure that your end user is not going to run into a situation where you deploy a new recommendation algorithm or so, and it turns out it wasn't as good, so you lose millions of dollars as a result of it. Now, oftentimes behind this is yet another pipeline that takes care of things like security guardrails and some of the governance requirements. Now, why is that important, and what role does the cloud play here? The cloud offers you all these managed services we talked about beforehand that simplify setting this up. So in a first look, that often looks very complex, but it's actually not so hard anymore when you have these managed services available, and also not so much anymore when a few of these workflows are already templatized for you. Now, the second thing I want to talk about, because I think it's very important, are new roles that I think are going to emerge over time. Now, in particular, we see that companies struggle to really produce value. I think we've just mentioned it before here as well, but it's such a crucial part, right? I think there's actually going to be a role coming up, and I called it a tech value lead here, but I think companies might come up with a better name, that has some sort of capacity to really enforce value, to really drive and push data science teams beyond their experimentation environments. That person is definitely going to have a strong technical background. They'll still be hands-on, yeah? but they'll also have very strong communication skills. They need to be able to influence other teams around them without having proper formal authority above them. I think they'll also have a strong interest in enabling the organization. They will be the ones that drive this into the business, that collect the use cases, that work with the teams to define the use cases and work with the data science teams to help them translate this. And they'll also hold people accountable for the ethical behavior of the models. If you look at this, we often see that customers have good intentions about using ethical AI and running all these checks, but oftentimes there's simply nobody holding them accountable to really do this for each and every model they train. Now, I want to very briefly dive a bit deeper into this part. If you look at how companies are reducing bias, we often see that they do this on 4 different levels. They do that at the very bottom when they start looking at data and they evaluate the data, whether it's unbiased, whether there is strong dependencies there. Then they do it in a second step when they have features and they evaluate whether they've introduced any bias in the process of creating these. Then they do it one step further when they do model explainability, when they work on feature importance and also understanding single predictions in order to make sure that there is no bias here. And also in order to gain user trust often. And lastly, they often do it in monitoring. If you run your models in production, you really monitor this consistently. You don't want to have that bias coming in over time, or you also want your data distribution to stay the same as it was when you use it for training. Now, that process is definitely simplified if you have a number of features and a set template for this to run this again and again with every new model you train, with every model that is retrained automatically. Now, the third topic I want to talk about is the rise of AI products. When I talked to a colleague a few weeks back and I asked her, what do you think is the future of machine learning in the cloud? She basically said, I see a bit of a divide coming up in data scientists that focus a lot on research, that focus on generating new methodology, and data scientists that drive value as quickly as possible. And I think the rise of AI products supports them a bit. Through the availability of AI services, that are services where the model is pre-trained, and you can basically run inference against it through an API call. And we see this coming up a lot in things like intelligent document processing, extracting information from text, right? A lot of these common use cases that a lot of companies have alike. Then they extract the text from a document, from PDF or an image. They want to afterwards do some topic modeling on it. They want to extract personal identifiable information. We see it in image recognition a lot, detecting a specific motion. We see it in quality inspection for manufacturing, where they are often trying to see whether there are scratches in the end product or there's a package that's not properly closed. See it in call center intelligence, transcribing calls, making sense of these calls, putting them into different topics. We see it in personalization with regards to recommendation algorithms, and we also see it in forecasting a lot. Now, these AI services do 2 things. They enable data science teams to focus more on the more complex tasks, but they also enable companies with no machine learning skills to at least leverage some of those for common tasks. Next to these AI services, we also see more and more software companies integrating these features in their end products. And that is primarily due to 2 reasons. A, yes, they have the ability, even if they don't have the skills. But B, they're also able, through a SaaS model, as opposed to the past where they send a CD to their customers to roll out their software, they're able to, patch things, etc., continuously, but also they're able to collect the data of their customers, so they sit on an extreme amount of information there. Now, the 4th point I want to talk about are ML methods becoming more mainstream. We talked a lot about organizational changes and some of the infrastructure requirements, but I also think that the cloud enables us to use some of these methods more frequently. Now, these are not new methods, don't get me wrong, but we have not seen them so much really running in production in the past. The first one of those is definitely transfer learning. Why is that? Because transfer learning in the first step requires a lot of compute capacity to train the base model. And with the rise of compute capacity being available, you're also able to train more and more complex base models. Now, the second thing you need there is a sharing platform. Companies like Hugging Face have really shown and paved the path for this. But now, oftentimes, they collaborate with cloud providers and make these base models available in the same environment with already existing recommendations and blueprints on how to use them. So that definitely increases the use of that. The next one is definitely generative AI. We see it coming up a lot in creative industries, in publishing, in media, in design, also in the creation of synthetic data. But oftentimes you need a fairly large upfront investment if you want to have the compute capacity available to run these kind of workloads. Now, if that initial investment decreases, you are able to just try this out for your use case, see whether it works or not, and if it doesn't work, you fail fast. And the last thing I think will become more relevant is GraphML here. We see it a lot in use cases that have very changing patterns, but also are very reliant on the relationships between things. We see this a lot in fraud management. We see it in life science when it's about detecting adverse events or when it's about generating new, more personalized medicine. And we also see it a lot in personalization and social media. Now, GraphML is essentially based on two things. One, you need a graph database available, and ideally that database doesn't have a license fee with which you commit to a user for the next 10 years. And the second thing that you need is probably an integration to your ML environment, and ideally that also doesn't differ so much from the environment you usually use. Now, all of that is a little easier there as well. The last thing I want to talk about is accelerated experimentation. This is more a result of multiple different trends rather than one thing at a time. We talked about the value in the beginning and how a stronger focus on value will also require an accelerated experimentation. It will drive the need for it. But there's also some of the other trends going on here. Data mesh, for instance. How many of you have heard of data mesh? There's quite a few. Well, data mesh essentially is a philosophy more than anything else about having business units be responsible for their data rather than having a central data lake team that's responsible for onboarding and leveraging that data. Now, at the bottom of data lake is also a data owner, someone who really makes the data available to the other teams around them. And besides that, you also have a button platform with some of the requirements around governance and also sharing capabilities, making sure that metadata is collected, that the metadata can be viewed by other teams. As a result of data mesh, all these individual machine learning teams won't need to necessarily wait anymore until their data is onboarded and prioritized by a central team. They are able to onboard their own data, leverage it, try something out with it, and then maybe collaborate with others to make it available to them as well. And lastly, MLOps, we've talked about it beforehand, having these common MLOps platforms, having some of the requirements already be there, will definitely accelerate experimentation as well. Now, to summarize a bit here, we've talked about machine learning industrialization in the beginning, where it's about data pipelines, where it's about retraining pipelines, inference pipelines, build pipelines. We talked about new roles emerging and something like a tech value lead. And we also talked about reducing bias in this context and how companies set themselves up to do this for each and every model. We talked about the rise of AI products, the availability of more AI services, but also the availability of software companies that provide this built-in, that can be content management platforms, that can be document ISVs. We also talked about mainstream ML methods, so methods that will become more mainstream in the next few years. We talked here about transfer learning, we talked about generative AI, and we also talked about GraphML. And lastly, we talked about accelerated experimentation as a result of a stronger focus on value, concepts like data mesh to make data available more quickly, and lastly, MLOps to really make that move into production. Thank you very much.